Hello, my name is Jan Sarabia, and this is my physics assignment presentation. And today, I am going to show you how I will calculate the height of my house without the use of a measuring tape and without trying to climb at the top of the house because that can be proven to be dangerous. The purpose of this experiment is to determine the height of my house by measuring the time it takes for a ball to fall from the rooftop to the ground, and subsequently applying the principles of gravitational acceleration to calculate the height. And this experiment provides an approximate height of the house without the use of a measuring tape. For my hypothesis, the height of the house, h, can be calculated by measuring the time it takes for a ball to fall from the highest point to the ground. And this experiment can be calculated with the equation, free falling bodies equation, where the height is equals to 1/2 times the acceleration times the time squared. And we know that acceleration is equal to the gravity because a ball dropping in the air is under the influence of gravitational forces, which is and we know that gravity is equals to 9.81 meters per second squared. So later on, as if once we find the value of the time, we have to switch the acceleration to the value of gravity. So velocity and acceleration. Due to gravity, any object, free-falling object, in this case a ball in this experiment, they tend to speed up as they fall towards the ground. So once a ball is thrown up in the air, its velocity will start to decrease until it hits zero velocity. The velocity then will start to speed up downward while the acceleration will remain constant, and the acceleration is under the influence of gravity, which would have a constant value of 9.81 meters per second squared. So this is my house right here. I drew a line on this picture. Well, the line represents the height, and the h, is the value I'm trying to look for. On this experiment, I decided to stand on this side of the house and decided to throw a ball up in the air, to the desired height that I want to, which is the highest point of the house. I want to throw it all the way to the highest point. As I throw the ball, its velocity will start to decrease until it hits zero velocity. Once the balls hit zero velocity, I will only have a fraction of a second to start the timer, and the velocity of the ball will then start to speed up again downwards because gravity is pulling the ball down. The ball will drop down to the ground. And from the highest point, I'll start the timer to calculate the time it takes for the ball to hit the ground. Like I mentioned earlier, the acceleration will remain constant as it falls down because of gravity. So I made several attempts, 5 attempts to be precise. On the first attempt, the ball took 1.78 seconds to drop down to the ground. The second attempt, 1.80 seconds. Attempt number 3, 1.82. Attempt number 4, 1.76. Attempt number 5, 1.79. See, these values are not, they're similar, but they're not exactly alike. So instead of using each attempt, it would not be very accurate to plug in on the equation later, we can just find the average of these attempts, and we can use the equation x bar equals to the sum of all the values of the data divided by the number of data, which can be represented to this Greek letter sigma, which is the sum of all the values divided by the n. I learned this equation from the statistics class this semester. So we can change the x bar into the t average because we're looking for the average time it takes. And we plug in all these values at the top, at the numerator, 1.78 plus 1.80, and so on. And you divide it by 5 because you have 5 values here. I then got an answer of 1.79 seconds. So that is the average time it takes for the ball to fall from the highest point of the house to the ground. So we can start plugging in the values now, where the h equals to 1/2 times the 9.81 meters per second squared, because we're dealing with gravitational forces on the ball, times 1.79 seconds, which is the time average, squared. And that gave me an answer of 15.7 meters or 51.5 feet. So to conclude this experiment, we successfully measured the time it takes for a ball to fall from the rooftop of my house to the ground, and used this data to calculate the height of the house. By applying the principles of gravitational acceleration, we were able to determine the height of my house to be approximately 15.7 meters or 51.5 feet. That is it for my presentation. Thank you so much.